Okay, the next indefinite integral we're going to consider is of the form the indefinite integral of 1 over u du. So we're used to thinking in terms of x. So what if we had the indefinite integral of 1 over x dx? Can we think of a function whose derivative is 1 over x? And hopefully we would think of the ln of x. That is a function whose derivative is 1 over x. What about the derivative of ln of negative x? Notice that if we took this derivative, the derivative of ln of negative x, well, that derivative equals 1 over the inside stuff times the derivative of the inside, which is negative 1. And this now would become 1 over x. So notice that both of these, whether it's a positive x or a negative x, has the same derivative of 1 over x. So since this can be a positive or a negative, we'll rewrite this as the ln of the absolute value of x. So therefore, the indefinite integral of 1 over u du equals the ln of the absolute value of u plus c. Because as we could see over here, whether the argument of the ln is a positive x or a negative x, both of them yield the same derivative, 1 over x. So since the inside can be positive or negative, we'll rewrite this as the ln of absolute value of x. So the indefinite integral of 1 over u du equals the ln of the absolute value of u plus c. Notice that the power down here in the bottom is the first. And if we rewrote that as u to the negative first, and you try adding 1 to that, using the rule u to the nth, increasing by 1, dividing by the new power, when you'd add the 1 to the negative 1, you'd get u to the 0, and you cannot divide by 0. So therefore that would tell you that something is wrong, that you cannot use that power rule. Okay, so some examples using this one. The indefinite integral of 1 over x plus 1 dx. If you choose the u to be the bottom now, x plus 1, du would be equal to 1 dx. This would become the du, this would become the u. So this would be equal to the indefinite integral of 1 over u du, which equals the ln of the absolute value of u plus c, which equals the ln of the absolute value of x plus 1 plus c. Okay, so some more examples on this one. If we have the indefinite integral of x over x squared plus 1 dx, if we choose the u to be the bottom, x squared plus 1, looking to get back a derivative that's in the integrand. Well, du would be equal to 2x dx. So we've got this derivative in the integrand, provided we put in a 2 and take out a 1/2. Now this would become 1/2 the indefinite integral of du over u. This would become the u, this would become the du, and then now this would become 1/2 the ln of the absolute value of u plus c, which is 1/2 the ln of the absolute value of x squared plus 1 plus c. Okay, another example is the indefinite integral of x minus 2 over x squared minus 4x plus 4. So here in this one, if I choose u to be x squared minus 4x plus 4, du would be equal to 2x minus 4 dx. But notice if I factor out a 2, I'd have x minus 2 dx then. By factoring out a 2, du would be equal to 2 times x minus 2 dx. Well, I have this in the integrand, provided I put in a 2 and take out a 1/2. And then this now would become 1/2 the indefinite integral of du over u. This would all become my u, which would be 1/2 the ln of the absolute value of u plus c, which would be 1/2 the ln of the absolute value of x squared minus 4x plus 4, close it, plus c. Okay, and one more on that is the indefinite integral of secant squared x dx over 1 plus tangent x. So if I choose the u to be the bottom, 1 plus tangent x, du would be equal to the derivative of 1 is 0. The derivative of tangent is secant squared x dx. So this would now become my du on top over u. This becomes my u right here. So then that antiderivative would be the ln of the absolute value of u plus c, which would be the ln of the absolute value of 1 plus tangent x plus c. And just a few more interesting examples, even though they may not use that form. Suppose we have the indefinite integral of 2 plus the ln of x cubed all over x dx. So here, if we choose u to be 2 plus the ln of x, du would be equal to, the derivative of 2 is 0, but the derivative of ln of x is 1 over x times 1 dx. And now I have that 1 over x dx to become the du, and this would be my u. So this would become then the indefinite integral of u cubed du. So it's not of that form 1 over u, so don't assume that they're always going to be like that. So this was just the traditional u to the nth. So that antiderivative would be u to the 4th over 4 plus c, or 2 plus ln of x to the 4th over 4 plus c. Okay, and one more example on that one. The indefinite integral of 1 over x times ln of x squared in the bottom dx. So if I choose the u to be the inside stuff of the quantity, ln of x, then du would be equal to 1 over x dx. That derivative is in the integrand, so this would now become my du, and this would become over u squared. I can make that u to the nth by making it u to the negative second du. Careful here that when you add 1 to that, you get u to the negative first divided by negative 1 plus c. So that answer would become negative 1 times the ln of x to the negative first plus c, or negative 1 over the ln of x plus c. Okay. Another one, if we had the indefinite integral of ln of x over x dx, again, just choose the u to be the ln of x. Du would be 1 over x dx. This would become my du, and this would become my u. And that antiderivative would be u squared over 2 plus c, or the ln of x squared over 2 plus c. Okay, so again, the last couple here did not have of the form 1 over u, but that's okay. We need to see them blended and mixed up anyway. So the last couple were some good examples, even though they didn't pertain to the form 1 over u du.